Have you ever stopped to wonder how your phone just knows that an email is spam? Or how a website can instantly tell if a product review is glowing or, just terrible? It really does feel like a bit of magic, but it's not. So today, we're going to pull back the curtain and really get into how we can teach a computer to understand something as human as language. Everything really boils down to this one simple question. Let's say you're a computer. You're given a bunch of text about a movie. How on earth do you figure out if the person who wrote it absolutely loved the film or if they hated every second of it? That's the fundamental challenge we're trying to solve. Okay, let's make this real. Here are two actual movie reviews. The one on the left is positive. The one on the right, well, it's pretty harsh. For you and me, it's totally obvious which is which. But for a computer, it just sees a jumble of letters and words. So how does it learn to spot the difference? So how do we bridge that massive gap? Well, it's not a single trick, it's a process. And we're gonna walk through that exact process step by step to see how a machine goes from staring at meaningless text to actually understanding sentiment. It's a really cool journey. All right, section 1, words into numbers. This is the first and honestly the most important step. Computers don't speak English or French or Japanese. They speak one language and one language only, math. So to teach them anything about our words, we have to translate them into numbers first. The classic way we do this is with something called the bag of words model. And it's a wonderfully simple idea. Just imagine you take a movie review, ignore all the grammar and sentence order, and just throw all the words into a big bag. Your only job is to count them up. It's kind of like turning a sentence into a recipe's ingredient list. What this process really does is create a unique numerical fingerprint for every single review. First, we build a giant master list of every single word we've ever seen. That's our vocabulary. Then, for a specific review, we create a kind of scorecard and just put a 1 next to every word from the master list that appears in our review. And just like that, language becomes math. So just how big is that master list of words? For the movie review dataset we're working with, it's almost 75,000 unique words. That means every single review gets turned into a list of 74,849 numbers. That's the kind of scale we're dealing with here. Okay, we've got our numbers. Now for the fun part, the learning. And to really understand what's happening under the hood, we're not going to use any fancy libraries just yet. We're going to build our classifier from scratch, the hard way, using one of the simplest algorithms out there. Let me introduce you to the perceptron. Think of it as a really basic decision maker. It starts by giving every single word in our vocabulary a score. Words like great or amazing will hopefully get a positive score, and words like terrible or awful will get a negative one. To classify a review, it just adds up the scores of all the words in it. If the total is positive, it predicts a positive review. If not, it predicts a negative one. The real magic, though, is in how it learns those scores in the first place. And the way it learns is just a simple loop of trial and error. The model takes a review and makes a guess. If it gets it wrong, let's say it predicted positive for a review that was actually negative. It goes back and just slightly nudges down the scores for all the words in that specific review. It does this over and over and over again, thousands of times, slowly but surely getting smarter with every single mistake. Now, here's a really important little detail. To make sure the model doesn't just, memorize the answers in order, we do something simple but crucial. We shuffle the reviews before each round of training. This forces it to learn the general patterns of positive and negative language, not just some quirk in how the data was sorted. So after all that, how well does this super simple, from-scratch method actually work? Well, it gets an F1 score, which is just a fancy way of measuring accuracy, of 86.8%. I mean, that's incredibly good. It just goes to show that this fundamental idea of learning from your mistakes is really powerful. Building something from the ground up is the best way to understand it, for sure. But it's not how things get done in the real world. So now, let's see what happens when we switch gears and upgrade to a professional toolkit like PyTorch. And wow, the difference is night and day. On the left, that's what we just did, writing all the code ourselves to figure out the mistakes and update the scores. But on the right, that's the PyTorch way. It's literally 2 commands. Loss.backward automatically calculates how wrong the model was, and optimizer.step takes care of updating all 74,000 of those word scores. It's amazing. See, PyTorch bundles up all these complex concepts into these neat little building blocks. The model is our decision maker, the loss function is the tool we use to measure mistakes, and the optimizer is the engine that actually updates the model. And the best part is, you can easily swap them out to try different approaches. And really, this is the main takeaway here. These professional libraries let us think at a much higher level. We can focus on the strategy of our training, make a prediction, measure the error, update the model, without getting totally lost in the weeds of the complicated math that makes it all work. So, we've pretty much mastered telling good reviews from bad ones. But what happens when the problem gets a little trickier? Let's take everything we've learned and apply it to a brand new challenge: sorting news articles. Right, so instead of a simple yes or no, positive or negative choice, what if we have to sort things into several different buckets? This is what we call multi-class classification, and it's a problem you see all over the place in the real world. For this next task, we're going to use the AG News dataset. The model's new job is to read a headline and a short description and decide, is this article about world news, sports, business, or science and tech? The core ideas are all the same. We just need the model to be able to choose from 4 options instead of 2. And just like before, getting the data ready is absolutely step 1. This pipeline looks pretty familiar, right? We load the raw data, we break the text down into individual words, and then we turn those words into numbers. It's the exact same fundamental process we used for the movie reviews, just pointed at a new target. So, how did our model do on this harder task? The results are, well, they're fantastic. If you look at those F1 scores, our accuracy metric, we're seeing numbers way up in the high 80s and even into the 90s. The model is amazing at telling a sports article from a business article. This proves that our basic approach scales up to more complex problems beautifully. Okay, so we've been on quite a journey here, from basic words all the way to some real machine intelligence. What are the big ideas we should walk away with? Let's boil it all down. First, and you've heard me say this a few times, preparing your data well is absolutely critical. Second, this whole idea of machine learning really just comes down to a simple loop. Make a guess, see how you did, and adjust for the next try. Third, the Pro Tools are all about handling the messy details for you so you can build powerful things faster. And finally, these core principles we've covered, they aren't just for one problem. They scale from simple 2-choice tasks to much, much more complex ones. And that really leaves us with one final big question. We've just watched a machine learn to understand emotion in text and categorize topics in the news. This is so much bigger than just sorting articles. We're fundamentally teaching a machine a human skill, how to read. And the real question is, what are we going to ask it to read next?